I'm going to lead us through our first notebook. So you can find it here in the resources folder. It starts with a 01. And this is going to kind of be an overview of some basic tools in Jdaviz, and it's going to highlight some of our new features, such as being able to use image viewer, spectral viewers all in one application at once, using Astro Query through Jdaviz, and loading data. So yeah, let's go ahead and get started. Before we get started, though, I want to just kind of go over the general structure of this notebook. So in the demo, I'm going to be using the GUI. I'm going to be using the UI, and clicking to do everything. So you're welcome to follow along with me. You're welcome to just watch. But if you want to revisit this notebook later and kind of recreate what we've done, there's two options. So you'll see that there are a bunch of screenshots here. And this is going to show every step what the UI should look like. So you can follow through these, recreate the series of clicks that we've done to run through this notebook. And then at the end of the notebook, there is going to be all of the API calls associated with what we've done in the UI. So this is part of the magic of Jdaviz. You can create completely repeatable workflows that you can share in Jupyter notebooks with collaborators or students. So it's a pretty powerful aspect of Jdaviz. You can set plot options, you can load data all through the API and create completely repeatable workflows. So if you just run all these cells with this button here, you will effectively get what we're going to do live today. All right, so let's get started. So step one of running Jdaviz in a Jupyter notebook kind of always looks the same. This is the convention that we tend to use in our documentation. It's import Jdaviz as JD, and this gives you access to the application object that you can interact with. And if you want to use the UI, you just do jd.show. You could leave this blank and just have the two parentheses, and the default location for Jdaviz would be inline in the notebook. Today we're going to use it in the pop-out window. There's other options like sidecar where it will be alongside your notebook, so you can see your cells and your Jdaviz at the same time. It's a pretty popular option. Today we're going to do the pop-out window. So let's go ahead and run that. If this is your first time running Jdaviz, it might take a minute. That's really only on the first import, and it will get faster subsequent runs. So let's see. Also, I'll just note, make sure you're in the correct kernel, and then make sure, depending on what browser you're using, that pop-ups are enabled. So I'm going to click this because I'm in Safari, and it is loading the app here. Okay. All right, so as Sarah showed, this is kind of what you see when you first start up Jdaviz. This is the menu, or I guess, yeah, called a menu. Data loading tab. You can also create new viewers, but for now, we want to load data into this application. So there's several different sources for data. So you can load files on your file system. You can just drop a file from a Finder. Data directly from a URL. So this is where you would go if you wanted to load data from Mast. Object. So this is nice if you're running this in a Python or a Jupyter notebook. You can upload Spectrum objects. You can upload ND data objects, etc. from your current Python session into Jdaviz. And we also have access to Astro Query and Virtual Observatory. So today we're going to show using the URL loader and loading data directly from Mast. So if you know your Mast URI for your data set, which is a unique identifier, you can load it. You can download data to your machine, cache it if you would like. We're going to do that here, and load it into Jdaviz. So go to, if you're following along with me, the load data cell in the notebook has the URI that we want. So this is going to be a star forming region, chameleon 1 it's called. So you can copy and paste that and put it here. It makes sure it's a valid URL. So this is going to take a few minutes. This is a 3 GB file. And we're all downloading it at the same time. So this might take up to 2 or 3 minutes. So we'll pause here for a sec. If you want to work on that survey that Sarah showed, that now would be a good time. But I will resume once this is loaded. And you'll see here you get a bit of an indicator of what's happening. So right now it's searching for valid formats, which means the data has already downloaded. It's just trying to automatically determine from the structure of the file what kind of data it is. So it will determine that this is an image and give you all the necessary parameters for loading images. So we'll give this a sec. All right. So now this is giving us a bunch of options for loading this data set into the app. We're going to keep most of these as they are. So it's determined that it's an image. By default, it only imports the Sci1 extension. You can simultaneously load other extensions from the FITS file as well. It gives it a default data label, which is just its file name from mast, essentially. This would be the same thing if you were loading it locally. We'll keep that for now. And the only thing we're going to change here is align by pixels. We're going to change to WCS. So you can do this after you load data, but you can also do it while you're loading data. So this will put the entire application in sky coordinates, and it means that when you hover over an image, you'll see the ARIAN deck. When you load another image, it will align them by their WCS instead of pixels. So we can do that now. If you wanted to do that after loading data, you could also do that through the orientation plugin. And we don't have any viewers in the application at the moment, so this is going to create a new viewer and call it image. So let's do that. Let's press import, take a sec, and there we go. So like I said, there's more info about this particular data set in the notebook, but this is the Chameleon 1 star forming region. And we've got it loaded into the app. So the next thing I want to show is how to rename data sets. So you could do this through the API, of course. You could interact with the data menu via API, but I'm going to show how to do this in the UI. So click on the data menu, and we have the kind of long, uninformative name. Well, I guess it is informative, but let's make it a little more informative. So if you hover over the data label, you get this little pencil that pops up, and we can call this whatever we want. I'm going to call it Chameleon 1 southeast side. If we were to load more observations from this program, we could give them other labels so we know exactly what we're looking at. So press that little check and it will rename the data set. Another thing you might want to do when you first load data is adjust your plot options to better see different features in your data. So this is applied the default settings. It's a grayscale. It's got a linear stretch function. But to adjust that, you can go to settings and options and go to plot options. So we only have one data set in the viewer right now that's already selected. If you had multiple, they would appear as little tabs here, and you could select which data set you want to modify. We're going to go ahead and change the color map to Viridis, and that'll automatically apply. And just from prior knowledge of playing around with this data set, we know that we are happy with keeping this stretch function, but we want to adjust the vmin and vmax. So there's additional options down here, and we're going to go ahead and set that to vmin to 0.4 and vmax to 0.85. And those automatically apply. You don't need to press enter or update or anything. Yeah, there's a bunch of options you can play around with and tailor to your data set. All right, so let's head back to AstroQuery. So something you might want to do with data planning might be to see what other observations have been done in this field of view. Have any of the stars, there's a bunch of protostars in this particular scene, have been observed by Webb. So we can actually do that through Jdaviz. So we're going to go back to the loader here, add data or viewers, and we are going to click from URL, and we're going to go to AstroQuery. So this gives you an interface to AstroQuery through Jdaviz. You can actually see what's happening from the tables that are returned in AstroQuery. So we're going to go ahead and select our image viewer. Oh, sorry, I actually missed a step. We want to look at one particular star in this field of view and see if there's any observations of that. So the way that you kind of define regions of interest in Jdaviz in image viewers or in spectral viewers, we use the term subsets. So there's a few ways to create subsets. You can do it from the viewer menu up here, There's also a subset tools icon up here, but I'm going to use this, and I'm going to create a circular subset, and I'm kind of just going to plop it down because we can adjust the parameters of it later. So there we go. We've got a subset, and we have the centroid of it as prior knowledge. So I'm going to go ahead and enter those coordinates. They're in the notebook. So it's 166.59019 for the RA center. And then the deck center would be negative 77.39823. And again, those are in the notebook. And we want to adjust the radius to 0.001. So you do need to press update for this. And you'll see that it's now centered on a star here. I'll zoom in. There's zoom tools. This is a box zoom, so you can, there we go. It's on our star. So yeah, let's go back to the loaders and see if there are any observations of this star. We know that there are, obviously, so we chose it for the tutorial, but I'm going to press, so we've already selected the viewer. I'm going to press follow viewer center just to make sure that this kind of stays at the center because there's going to be a lot of footprints that pop up. There's a lot of observations in this field. So we've zoomed to roughly centered on this, so that will remain. And once we press query archive, it might take a second. This is running Astro Query behind the scenes, and it's going to show us a table of every single observation that's been done in this field. If we want to see the footprints of these observations, we can press Enable Footprint Selection Tools, and all these orange boxes will pop up, and these are all the footprints of every observation and that Astro Query has returned from this field. So once you press Enable Footprint Selection Tools, this toolbar will pop up, and of course if you disable them that will go away, but we want to enable this tool. So if you hover over each of these tools, they'll kind of give you some information about what they're doing. This one is the nearest edge selection, so this means when you click on your viewer, it will select the nearest footprint to wherever you've clicked. So we're going to use that one. And we want one of these near spec observations. We know this is a near spec, the footprint of a near spec slit. So let's go ahead. We've enabled that, and we'll click here, and it selects that. So once you've selected one of the footprints, if you scroll down here, it will not only show all the table of all the observations in this image, in the field of view, it will show all of the observations associated with this. So we want to select the X1D file at the way end of the table. This is the level 3 calibrated spectrum. And we can load this into the app, and it will pop up a Spectrum 1D viewer of this observation. So this is another way to load data from MAST. So I've selected that. We're in the loader, so it's going to pop up some of the same options. It knows it's a 1D spectrum. We're just going to import this extension. It gives it a default label, and it will call it 1D spectrum by default. And I see in the chat that people are having issues with data. If the file's not cached, this could take 5 minutes to load. It really depends. I've had it load quickly. Sometimes it takes a while, so just be patient. And again, you can run through the notebook on your own time. I'm also here to answer questions after this presentation. So sorry about that. I know it's a large file. Okay, so we're going to load this spectrum, and it's going to create a 1D spectrum viewer because we don't have any of those in the app. If you already had a 1D spectrum viewer, you could choose to add it to that viewer rather than creating a new one. So let's do that. Import. And this is a small little bug we need to fix. It's the default zoom limits. So just press home on there. And here's our nice, beautiful 1D spectrum. So there is information in the notebook about what we're looking at here. There's some cool features, some absorption. One of these is, this is carbon dioxide ice, and one is carbon monoxide. I don't remember off the top of my head, but they're in the notebook. And yeah, so this is another way that you can load a 1D spectrum. If you knew this URI off the top of your head already, you could have loaded it the same way we loaded the image. But yeah, I will end this notebook here.